Alright, today we're going to be learning about motion and how objects can change their speed, position, and direction. So real quick, get out a piece of notebook paper. As long as it's a piece of paper. Put your name on your piece of notebook paper and give me a thumbs up when you have your name on it. Put your name on it, and then give me a thumbs up. Alright, this is what I want you to do. While the video is playing, I want you to write down the different ways that objects can move. The video is going to give you a lot of examples. So when the video talks about those examples, I want you to write down as many as you can. So when the video is over, I'm going to take up your notebook paper. So before the video is over, you need to write down some examples, correct? Okay.
At Wayfair, we get pretty excited about furniture. Around here, it's not a patio, it's patio. Oh, I love those chairs.
Shed
Things around us move in different ways. How can you describe the way things move? Things can roll.
Things can roll. That can be an example.
Slide.
Slide.
Bounce.
Bounce.
Things can fly through the air.
They can fly.
Things can move in different directions. They can move back and forth.
They can move back and forth.
Up and down.
Up and down.
Or round and round.
Or round and round.
Things can move at different speeds. They can move slow or fast. How can you describe the way things move? Catch you later.
Alright. Make sure your name is on your paper and pass it up to the front for me.
what they were saying. I was like, Home Depot. And I just put the commas.
I would just put I think that's the shortest video we've ever watched.
It is. But it had the most. No, we watched one that was like 45 seconds. We watched one that was 1 second.
I know.
Yeah, it was a YouTube short. In scope, we watched an 18-second video and we got some.
I just wanted at least that
huge.
huge.
Put left again. Back and
Up and down.
Oh, Brad.
All right, who wants to share what they wrote down? Trinity?
I want to put the one that can roll, they can go back and forth, they can slide, they can bounce, they can
Okay, Brayden. They can be pushed or they can be pulled. Chase?
They can roll, slide, bounce, go side and side.
Yes, Bracklin.
They can go fast, slow, they can spin around,
Yes, Jacob.
they can do wheels,
Yeah,
they can run really fast.
Franklin.
They can go up and down and bounce.
Yes. So objects can move in a lot of different ways, and not only can these objects move in different ways, but we can, right? All right, I have my stickers somewhere. Yeah, my magic stickers. Okay. What is the invisible force that pulls objects or keeps us on the ground? Hendrix. Gravity. Because we talked about that yesterday, right? Yes? No? Maybe? Yes. All right. How does gravity affect us? What does gravity do to us? Jesse?
Gravity keeps on the ground.
It keeps us on the ground. Yes, it does not let us fly. So what is mass? Remember, mass is a fancy word for, yes, Brayden? Weight. So if something has a lot of mass, that means it's going to have a lot of, everybody tell me, weight, or a lot of gravity. So the bigger the object, the more gravity it has, the more it can pull something. Because what does the sun pull around it? Everybody tell me. The Earth and all the planets. Yes. Because the moon is a natural satellite. I love it. So how does gravity help us stay on the ground? It does what? Everybody tell me. It pulls us. All right. What does the word direction mean? When something changes its direction, what does that mean, Paxton?
They changed the ways of going.
And what were the different directions that I told you about when we learned about compasses? What was that saying that I told y'all about?
Never eat sour
Never eat sour watermelon. And that stands, what does it stand for?
East, southwest.
Yes, those are the different directions we can go.
Never eat soggy worms.
Yes, never eat soggy worms. So what is speed? Remember, we talked about how we can change our speed. What is speed, Levi? Emotion. Or how fast or slow something can go. So what is force? Everybody tell me.
A push or pull.
A push or a pull. Yes. Yes. So, how can force, a push or a pull, affect the direction or the motion of an object? How can force affect the motion of an object? How can force cause something to move, Cherokee? It can push it or pull it to make it keep going. It can make it change its speed, or it can cause it to spin or go round and round. So what does the word motion mean? Motion basically means to what, Chase?
Where you like move.
Move. So motion is a fancy word for move, just like mass is a fancy word for weight. So if I build a ramp, everyone knows what a ramp is, right? So if I put a ball at the top of the ramp and I roll it, how does force affect its speed? What's going to happen to that ball's speed when it goes down the ramp, Bracklin?
It's gonna make it go fast.
It's going to make it go fast.
Yeah.
I love it.
That's what
So the force causes the ball to speed up as it moves down the ramp. So what do you think our world would be like if we did not have any motion? What would it be like, Lily?
we would be stuck forever.
We would be stuck forever and we would be very still.
We'd be paralyzed.
Yes.
Paralyzed.
Okay, it's our big thinking question. Why do you think it is important for us to learn about motion? Why is it important for us to learn about how objects can move and change their motion? Avery? Why is it important for us to learn about motion? So we know how it works and how objects can change their direction or their speed. So, y'all see, y'all been talking about it all morning about this little balloon that I have on here. And you kind of got a little deflated, so I might have to blow it up a little bit more. So,
Oh wait, I know what's gonna happen.
what's going to happen?
The balloon is gonna fly up into the air until it runs out of the air and it'll fall on the ground. Is it helium or air?
I don't know. We're going to see. Oh, there's a hole in it.
There's a hole in it?
Yes, but I brought another balloon.
Hey!
So that's okay. I was smart to think about to bring more balloons.
How many you got?
I got two. This one's a lot bigger.
Yeah. Load up the piano.
Oh, yes.
That's it. I think I like it. It's gonna go. It's just gonna go fast. Fast. I'm gonna have it.
Okay. So I blew it up really, really big. So now, you see I have a straw. I'm going to tape the straw to the balloon. Can someone grab me some more tape? Trinity, can you grab me the tape dispenser?
For the whole thing?
Mm-hmm.
It's a hole.
In the video, it said we have to tape it very good.
Well, what's gonna happen?
We're going to see.
They probably use duct tape though.
Probably, but I didn't have any duct tape at home.
I have duct tape. In my house.
Okay. I think this should be enough tape. Okay. So you see, everybody look up here. I have the straw on a string. So, I kind of threaded the string through the straw. What do you think is going to... So, does the balloon have any motion right now?
No.
It's not moving. What do you think is going to happen when I let go of this balloon?
It's gonna fly and hopefully pop.
All right.
It's gonna fly.
Count down from 3.
3, 2, 1.
What happened?
It hit the next button.
What happened to the motion of that balloon?
All the air went out.
All the air went out. It went fast. So tell me what happened to the motion of it. It went from it kind of went from side to side.
Left to right.
So now the balloon didn't have any motion before I let it go, right? But when I let it go, it did what?
It flew.
It went really fast and went from side to side. Now, if I took that string and I put it in different ways all across the classroom, and I put a lot of air in that balloon and I let it go, what would happen to it?
It would go nonstop.
It could go from left to right, it can go up, down, side to side. So what I made was a balloon rocket. And so before I let the balloon go, it did not have any motion. But when I let it go, it sped up. It went from side to side. So was there any force being used?
Yes, ma'am.
How was force used? I didn't push the balloon, but there was what inside of the balloon? Air. So do you think that air forced the balloon to move?
Yes.
Because all the
you were holding the little thing that stopped
Mhm.
the air from coming out before.
because all the air came out of the balloon and it kind of gave it a what? Push. So, do you think force plays a role in motion? Do you think force and motion have a lot to do with each other whenever objects move? Because sometimes in order for objects to move, we have to push it or pull. So, I used the wonderful thing on my computer and I put y'all in random groups.
Yeah.
So, this is what you're going to do. Before I call you to your groups, you need to get your social studies book and you need a pencil, because what you're going to do in your groups,
Is it the same group?
no, they're different. So listen. What you're going to do in your groups is you're going to use your books to make a ramp. Everyone see my ramp on the board? You're going to make a ramp. You can use your binder as well and your book. So what you're going to do in your groups is you have to work together to make a ramp. And what you're going to do is you're going to put your pencil at the top of your ramp and your pencil has to roll.
I know.
You can stack your books on top of each other
Oh, can I do this?
and have a book sideways
I should be good
to
at
make
this.
a little bit of a ramp.
All
All right, so listen for your groups. Group 1, Olivia, Levi, Gatwin, and Franklin. Come sit on the floor over here. Scoot over as far away as you can. All right. Group 2, Cherokee, Paxton, Trinity, Jacob. I know, it just randomly does it. I don't do it on purpose.
We can do this.
Y'all sit kind of closer to the other group.
No, why don't
Yes, y'all can use a book.
we do this? Why don't just
All right.
find a way to
Listen, Jesse, Avery, Grayson, Lily. Sit right here. Get a book and a pen.
already made one.
We get all right. Group 4,
right here.
Bracklin, Chase, Luke. All right, come sit over here. All right, last group. Drake, Hendricks, and Braden. Y'all sit right here. All right, y'all start working together to build your ramp. And use your pencil and put it at the top of the ramp so the pencil can roll.
We made a wheel. Project 1 didn't work. Project 6
Work together.
Miss Madison, look.
And your ramp doesn't have to be just like mine. Alright, wait. When you're done with your ramp, call me over and I'm gonna see your pencil. Alright, I'm coming. Let me see. I love it. Alright, go back to your seats.
Wait, what about our stuff?
Yes, get your stuff and go back to your seat.
Is it graded?
Yes, I love it.
Okay.
When you're done with your ramp, call me over and I'm gonna come look at it.
Somebody in our group wants their books. Look at theirs.
Yeah, put all your books together.
That's not gonna work. Here, y'all can use this.
Okay, we're ready.
We're done.
Alright, let me see this group. Awesome. Alright, take your stuff and go back to your seat. Alright, who's done over here? Awesome, go back to your seat. Let me see. Alright, go back to your seat. It's okay. I wanted them to all be different.
Ours was different.
It was. Everybody's was different. Huh? No. I'm looking. All right, roll it. Awesome. Get your stuff and go back to your seat.
Yeah. That was just like.
Awesome, awesome, awesome. Okay. Raise your hand and tell me, what happened to your pencil? What happened to the speed of your pencil when you pushed it on the ramp? Raise your hand. Franklin.
It rolled down the ramp.
It rolled down the ramp, but what happened to the speed of it when it rolled down the ramp? Luke?
It increased.
It increased. It went faster. So, how did the location of the pencil change? Did it stay in the same spot when you rolled it? No. Where did it go? It went down the ramp.
It went to the bottom. It went to.
What direction did the pencil go? It went
Straight
down.
side to side.
Yeah, straight and side to side. So, did gravity play a role in your ramps?
Yes.
What did gravity do?
Push it.
It pushed it down,
But
it pulled it down the ramp. So when you put your pencil at the top of the ramp, did your pencil float away? No. What pulled it back down? Gravity. Yes. So how did force, which gravity is a type of force, did you have to push your pencil down the ramp?
No.
Did you have to push it?
No.
Did you have to, I mean, you at least had to move it just a little bit, right?
Just like
Some of y'all did. Some of y'all did. You didn't use a lot of force, but you used a little bit.
I like it.
All right. All right, I have a little worksheet for y'all to do. So when I give you this worksheet, put your name on it. We're going to go over the directions. It is 8:32. Because the spinning top is moving. It has motion. Alright, give me a thumbs up when you have your name on your paper.
I don't even have my pencil. They stole my
Well, you better get another one. Everybody has their name on their paper? Yes, no, maybe? Yes. Okay. So it says you can use force to make something move, stop, speed up, slow down, change its direction, or even change its shape. So you are going to draw the lines to match. It's giving you pictures of different things you could do, like kick a ball, squeeze clay or Play-Doh.
Schedule if you want to come on.
Get a schedule?
So you can come now if you want to.
And we can come back and finish your lesson before we go outside.
We can.
Okay, that okay?
That's fine.
Let me give you, she didn't tell me how. Okay, when I call your name, come line up. Hendricks, Jesse, line up in this order.